Welcome back, viewers. In today's video, we are going to check out the science packages of Edubuntu 23.04. Let us start. The first is atomics. We have checked this out. It is just a simple game of bringing the different atoms together in a maze. So you have to solve the maze also and then bring the atoms together. The atoms will join to form a molecule. For example, two hydrogen atoms plus one oxygen atom is randomly placed in a maze. You have to bring all the atoms together to realize the water molecule. Next is the chem tool. So in the chem tool, you have to use this to create the different can say molecular different molecules out of the atoms with the different structures like hexagon, pentagon. Okay, so different shapes of the molecules. You have to arrange the atoms with the different bonds. So the bonds are also there, covalent bond, other bonds are also there. Let us check this out. You can also rotate the molecule using the flip object. So the whole molecule can be rotated. You can draw brackets and boxes around the object. So you can also show chemical reactions. For example, can say complex hydrocarbon molecule is there. So you can draw the brackets around the two molecules and you can show with plus sign, so and equal to sign, and then show the resultant compound or a molecule that is formed out of the reaction of two different complex hydrocarbon molecules. So something like that you can do it here. You can also remove the duplicate bonds. There are also some templates. You can see here the different bonds are there. So this is the pentagonal bond, hexagon bond is there. So I think this is benzene. So different bonds are there for the different complex molecules like the hydrocarbons, the plastic phenaphetyl, you can see here, biphenyls, indene. So this is alkene. Fluorine is there. Fluorine is another alkene. So this is Deccan molecule shape. Heptylene is there. So it is, I think, derivative of ethylene. Fulvalene is there. Dicyclopentadiene is there. So this is the steroid backbone. So the different steroids that we take. So this is the simple structure of the steroids. Cycloheptadine is there. Naphthalene is there. So this is the naphthalene bond that is shown. So there are I think 5 double bonds are there in two hexagons attached with each other. Azulene is there. This is benzene. So this is the benzene. I remember in my 12th standard we had studied this. Benzene is there. So these are all carbocycles. The different sugar molecules are there. So you can create these molecules here only. So this aids to clear the we can say the doubts in the minds of chemistry students. So different sugars are there. Fluoranose core is there. Ribofuranose is there. Fructose is there. So this is the shape for fructose. Galactose is there. Cyclose, glucose, mannose, sucrose, maltose, lactose. And this is the glucose molecule. For example, if I click on glucose molecule and then I have to close this, so you can see here this is the glucose molecule. This is how the glucose molecule structure looks like. So you have to use this, and the help files and tools, everything is there. You can even calculate the formula, molecular formula, the weight of the molecule. Many things can be done here. You can see here. You can also import molecules, import the molecular structures that you have drawn. Okay, so now we will go ahead. Calcium, we have seen light speed. I don't remember if I've seen the light speed. So what exactly is the light speed? So light speed is a simulator which can illustrate the effects of special relativity on the appearance of objects traveling at ultra high speeds. Depending on particular speed and one's point of view, relativistic effects can cause the object to appear shorter, longer, brighter, darker, deformed, or off color. To adjust the velocity, use the slider along the right side of the main window. You can also type in a value using the entry at the top right. Press enter once it is on. To change the unit shown, press the button on the right side of the entry and it can cycle through the small list. So the object travels in the positive x direction, which can be usually set by activating the object's coordinate axis. Okay, so let us. Okay, this is, I think. So when the light travels through this molecule or object, you can see the color changes because the our perspective or our viewpoint is changing. We said the object is moving, so our viewpoint is changing. So that's why the color of the object also changes. You can see it here, and the speed of light is also changing. You can see the speed at the top right. So this is the speed of light at meters per second. So as the speed of light increases, this object will be shown much darker. You can see here the ends are much darker, and when we reduce the speed of the light, the color changes from darker to some blue light. So it was earlier black or gray, now it has changed to blue. If we further reduce, it will change to more bluishness, and you can change this. So it is nothing but it is an experiment to show the students how the light travels, how the light can affect your visuals, and what is the effect of light on the different objects when it travels through them or it is incident on the objects. So it's very simple, but it is very helpful for students to clear their doubts about light. Then rocks is there. Rocks is, I think, some chemistry application only. Let's see. Some of the applications take some time to open up. Now first we will open the rocks handbook. Rocks is a graph theory tool for everybody interested in designing and studying graph algorithms. So I was wrong. It is not a chemistry, but it is a mathematical tool. It is a graph theory tool. If you remember, we had studied the graph theory, discrete mathematics and graph theory, that is DSGT, I think it was called. The subject was there in our second year, second or third year engineering. So that is this. So there is some code also. So it is useful for lecturers, students, and researchers, and everybody who is interested in data structures and algorithms. So you can study the data structures and algorithms using this graph theory tool. So how to use this and everything, it is you can say not subject of this video, because then the video will become very long and I will have to spend at least 1 hour to give you the basics. But we can cover this if you are interested in some other video. Next topic is we have completed Stellarium in last two videos are shown. I'm not going to check you out that, but we can go with the steps. Let us see what is there in the steps. Open the step handbook. So step is an interactive physical simulator. It allows you to explore the physical world through simulations. It works like this. You place some bodies on the scene, add some forces such as gravity or springs, then press the simulate icon on the toolbar, and steps shows you how your scene will evolve during the according to the laws of physics. So you can simulate the laws of physics acting on certain body. You can have the body, you can apply different forces on the body, and then you can simulate what will be the effect of those physical forces on that body. So this is basically the, we can say, a simulator experiment. So what we will do is, let us put a box here. position the top left top corner of the box. Okay, so box is now kept. Now we will do some, we have to apply some forces on the box. To do that, let us see what to do. Then we will apply a gravitational force on the box is created. Now you have to simulate. Stop. So the box can apply weight force on the box. Okay, let us stimulate. You can see when we apply the weight, the box falls down due to the gravitational force and the weight force that is applied on the top of the box. So this is very simple. It is a simulator. So students can learn the laws of physics way much better when you have got some visuals showing the action of the different physical laws on the body. So that is the use of this application. So it's very great application. Normally you don't see such applications in the classroom, but teachers can take advantage of such tools to make the student understand better. So we have, I think, completed the science applications. So I will now stop the video here. In the next video we will check out some more application packages. Bye bye.